Welcome, and in this video we're going to show you how to perform the dynamic white calibration for a fixture in ShowRunner. To do this, you will need a light meter capable of determining correlated color temperature. Typically these are best done with meters that have a CMOS type sensor. Those that use an individual red, green, blue CCD type do not give accurate color temperature calculations for LEDs because the LED light spectrum is not full spectrum. It's fairly spiky. So keep that in mind. It's essential that you have an accurate meter to give a proper result. Anyways, we're going to go ahead and go through the setup here. From the setup screen, we're going to go into load hardware. We're going to be adding dolly loads here. So we've got our DIN Dolly 2 selected. This is our demo program with a variety of hardware. Go to configure loads, and we're going to add a new load. We're going to put it on loop 2. We're going to put it on group 2. And now this will consume groups 2 and 3 on the dolly bus because we need to handle warm and cool. Then we're going to specify this as a warm-cool fixture. We're going to put it in the lobby. And we'll call this wall wash. Now, you'll see that when we change this type, the CCT setup appeared in the upper right-hand corner. We're going to go into the CCT setup. Now we've got our CCT setup screen. I don't have an actual fixture, but we're going to assume this one is a 2700 to 5000. So we'll go ahead and make an adjustment to 5000. Now we only support 50K increments. Usually no one can perceive that difference. So to keep it simple, we just provide those settings there. Now in this case, because it's a warm-cool, we do have a standard algorithm that will calculate the points between the two, and it does apply a curve. It's pretty darn close, but it's not necessarily going to give you an ideal result when you have the ability to calibrate the fixture. So we're going to turn on the Use Map Points feature. Now we've got no points defined here by default, but we know this one, it produces a 2700K at full warm, so we're going to set the warm to 20, so full to 2700. Set the map point to 2700 here. Now we can add the point, and this is going to snapshot our current warm-cool mix. In this case, looks like it was already set, so I'm just going to update the point here, and that'll clear it to 0. Now, you have to play with this, but our recommendation would be to basically adjust these settings until you get a lumen output and color temperature that is the desired level. We recommend calibrating the minimum, the maximum, and then the thousands and 500s in between. So our next point would be 3000. We're going to go ahead and set that. This will change it to an add point because we're adding a value that does not exist in the map table. And we'll make our adjustments here until we get our meter reading right, and then we'll go ahead and add the point. We'll repeat this process at 3500. Now you'll have to play with the fixture values to try and get a consistent output. We're just playing with these here. They're somewhat close to an approximation of what you might actually see in the real world, but keep in mind that we're just doing this without any actual fixture. And again, we'll make some further adjustments to try and hit 4000. And we'll go ahead and add this point. And then we'll again do 4500. And we'll make a further adjustment. Again, you want to try and hit the same lumen output, but at a different color temperature with these adjustments. Go ahead and snapshot the 4500. And then since this fixture, we're saying caps out at 5000, that's going to be full 100% cool. We'll change this to 5000. And you can add the point here. So now we have a complete map table, and the system will automatically interpolate between those values, generally producing a very desirable result. We've seen very good consistency across 5 or 6 different fixtures in the same area, all responding within 50K of the desired set point, something that will be imperceptible to any observers. If you do need to delete points, you can click on the delete. When you change values, it will automatically send the selected settings to the fixture. That one didn't capture. So you do need to set these sliders first before it'll capture them. If it has old values, it would get the incorrect value. So do make sure that you do set these sliders, which is something you're going to have to do anyway. So that concludes setting up this particular fixture for CCT calibration. We'll go ahead and we'll add another fixture at loop 2, group 4. This fixture will be an intensity CCT, as there are drivers out there that made by manufacturers that have the ability to perform the CCT calculation within the driver itself. In that case, we have one channel for intensity and one for CCT. Typically, those drivers are going to have a very linear response, and we'll assume this one does 2700 to 6500K. You can play with the values here just to confirm that the response is linear. If it is not, we've seen some fixtures that have like a dolly for intensity and a 0 to 10 for control, and they don't have a linear response because the driver has a logarithmic. So in that case, you do need to use the map points. You would turn this on and then set the map points just as you would on the warm cool, but you would typically only adjust the CCT. We won't save the intensity. Typically, we will calibrate that at 100% for the intensity and then just adjust the CCT until we get our typical 2700, 3000, and then the 500 increments up to the max. In this case, assume we've tested this fixture, it gets a linear response. We'll just turn the map points off, and we'll call this one good. Now we do have a feature if you've got multiple fixtures in the same area and one of them doesn't respond to the full range, like we have a 2700 to 6500K for this grazing fixture, but our wall wash we set up here only goes to 5000. We could turn on this turn off load if outside CCT range. So if the entire area went to a very cool temperature above 5000 Kelvin, the system would automatically fade out this particular light, and then when the commanded CCT came back in range, this fixture would be turned back on or faded back into use. So certain applications this may come in handy. It prevents the area from looking weird if you've got a light, say at 6000 and this other one over at 5000. That's a significant enough difference, it's going to throw the eye off. So use it if needed, it's available there. Now let's say we've got the same wall wash fixture, which we'll say this is called an F1 type in the diagram. We'll go ahead and add another load, 2 in group 6. Now we'll also call this a wall wash, but we'll put it in the open office. So wall wash, this is an F1 fixture type, and this is a dynamic white warm cool. We've got our CCT setup. Now, we've already performed the setup for our wall wash in the lobby. So we can go to the import settings, and we can find this other wall wash fixture F1 type. We do have some other fixtures in here that were made before that have settings. They don't have the map points. So this one's got the map points. We'll go ahead and import the settings. And here are all our values that we've already created. So if you've created one for a certain fixture type, you can reuse them throughout the program. Very handy for typical jobs, as fixtures typically repeat. Very easy to copy and avoids from having to perform that operation again. So that concludes setting up a dynamic white fixture within ShowRunner. Thank you very much.